Hello everyone. Today we are going to solve problem maximum number of vowel in a substring of a given letter. So in this problem, I will first explain the intuition behind this problem. Then we will derive a optimal algorithm for this problem. After that, I will write code in Java. Then we will analyze its time complexity and space complexity. So do watch this video till end. So let's start by understanding the problem first. So problem saying we are given a string s and an integer k. Return the maximum number of vowel letter in any substring of s with length k. Okay, and let's come here and understand the problem carefully. So the problem saying we are given a string and an integer k. What we have to do, we have to find a substring length k where the number of vowel is maximum. So let's analyze. If I take this substring of length k, here k is 3. I have, if I take this substring a b c, in that substring it is a length of 3. Okay, here how many vowel? Only one. So the vowel count is 1. Now move to another substring. Take this substring. Okay, in that case b c I, the number of vowel is 1 also, because here I is only vowel, rest 2 is constant. So here the vowel count is 1. Again we keep tracking the maximum vowel count. So in that substring it is 1, in this substring it is also 1. Let's take this example CIE, that is CII. In that case the substring length is 3 and number of vowel is 2. So the maximum count of vowel become 2. Take this substring from this I to this I, length is 3. That is the requirement of the question. We have to take only a substring whose length is 3. So if I take this substring, the number of vowel in this substring is 3 also. So the maximum vowel count become 3. Again I will check all the possible substring of length 3 and return the maximum number of count of the vowel. Okay, so do this. So the intuition is that this problem come under sliding window. Why? Because here we are given a integer k. This showing the window size, and the problem requirement is we have to maintain a window size, and and in that window we have to perform some task. In this case, the task is finding number of vowel. Okay. So the problem saying we have to maintain a window size like this. Window size 3, and in that window we have to find maximum vowel count. In this window find maximum vowel in this window, and we have to track and return the maximum vowel. So how can we do this? Window use two pointer approach. How? If we use two pointer so that we can find the window length. How we do that? Let's see here. So I said window, use two pointer idea. Let's take two pointer here like this, L and R. This two pointer like this. Okay. How can I find the window? Ask 10 questions. For this, I will run my this R pointer till window length become okay. In that case, now right now the window length is 0 because both L and R pointed to same. So in that case, window length is 1. Now I move my R pointer, window length become 2, and at this again I move my R pointer, and now my window length become 3. Now I will count the number of vowel in that window. Here I will count vowel count is 1. I will store it, and I again move my R window from to this. Okay, when I move my R pointer to this, my window size exceed the problem requirement is 3, but now my window size become 4. 1 2 3 4. So in that case I have to shrink my window. How we will do that? We shrink a window from left side to make the window size k. Now I bring my L one step forward to make window size valid, because problem requirement we have to maintain only k size window. Now it's again become k size window. I will, in this window I again count number of vowel, and I move my R. Whenever my window size exceed, I what will I do? I simply shrink my window from length like this, and again this become window length 3 C I will count the number of vowel, track that, move my R window. I keep doing this until my R reach the end. Let's say whenever my R is here and my L at this point, this is a valid window. I check number of vowel and I again move my R. When the S length gets end, I stop the for loop or my algorithm. Until now we have found the maximum vowel count. So this is the idea. I hope so it makes sense. The idea is simple. The intuition is very clear. Whenever you are given a fixed size and you are asked to maintain that size, and in that size, in that area, in that window, you have to perform some task. The sliding window helps. Okay, we understood the algorithm. Now let's come here and try to code it so that we get more sense how we can do this. So what we have discussed to in sliding window, we need two pointer. One pointer we keep moving, and whenever window size exceed, we shrink window from the left pointer. So for that I need a left pointer. So I take like this, L equal 0. Okay, what else I need? Let's come here and understand how, how we will count number of vowel in a string. For that, I iterate over this string. Whenever I found a vowel, I increase my count by one because this is the requirement. Let's take this example of this window ABC. Let's bring our pointer to this at their correct place. Now, this is my valid window. What I will do whenever I iterate over my window, right now, this is A, I will increase my vowel count by 1. This is not a vowel, so I won't increase any count. Here again, I won't increase any count. So, in this case, while iterating, I will count the number of vowel count. I will count number of vowel and simply track. This is the idea. How can we do that? For that, we have two data structure. One is set. What I can do, I use a set. What I can do, I will use a set, and in that set, let's choose black. Okay, I will use a set. In that set, I list all the vowel. What are the vowels? A, E, I, O, U. A, E, I, O, U. These are the vowels. I will list in set, and while iterating, I will ask in set whether that that character belonging to that set. That means that character is vowel, and I simply increase my vowel count. And if that character is not present in my set, in that case, I would know that character is not a vowel. So in that case, I can count number of vowels, and there is another data structure called hash map. I will use a hash map. Okay, and hash map only we will use hashing. How can we do that? I will use a array or hash, we can say, of fixed size. Here I will use a 128 character hash. And what I will do in that hash, I simply uh, increase I simply increase vowels count by 1. So what I'm saying, I will use a character hash uh, of 128 length because 128 length contain all the ASCII values and the alphabets in that range. So I will simply use a hash set hash, or what I can do for vowel like this at hash A, I simply increase its count like this, has like this, and I can increase or count for vowels, all vowels. And I simply, what I will do after that, I iterate over my string, and I keep adding has value, because whenever our count, whenever a character is vowel, for that my has give 1, otherwise it gives 0. Mm, it so it makes sense what I'm saying. I only increase value for the vowels count for vowel character like this, has A, has E, has I will increase its index value by 1, and I start iterating over my string. If it is A, it itself give me one value. If it is B, it give me 0. It is C, it give me 0. So till this in this window, my has give me total count of 1. In that way, I will count the number of vowel. It is more easy. And here I am using a fixed size of array, which give me a constant space as well. So this is much more better idea. We can go with this also, but it takes extra space, and we have to check every time whether a character is belonging to this set or not. But in that case, I can simply count, keep counting. If it is vowel, it contribute in count, otherwise it won't. That this is the simple idea. And we have understood, whenever my window size exceed, what I will do, I simply shrink my window. I keep moving my r. Whenever my r exceeding that k, I simply bring it to this. This is my idea. Let's come here again and code. We understood we need a left pointer. What else I need? I need a has. So of what length? Has is nothing but an array. Of what length? Let's call it chars. It store chars. Okay, chars of length. Let's call it chars of length 128. It is a fixed length, so it gives us constant space. Now I said for every vowel I simply increase its count. For chars E, A, what I do, I will simply increase its index value by 1, and I do same with other vowel. Here it would be E, now I, O, U. Let it should be O. Okay, this is how I can increase my chars value, vowels index value. Now what I will do, what else I need? I need a variable, max variable, which uh, track the maximum vowel count across all windows. So how can I do that? I simply I take a max vowel. Let's call it max vowel count. Max vowel count equal to 0. Now what else I need? I need a vowel count. For every window, I will count a vowel. Vowel into vowel. How many vowel in that window? For that, I use a vowel variable. Now what I will do, I run a for loop. It will be my r pointer because it start from 0 to end. So it run from 0 to end. How long? Till s gets end. So for that, I simply run of this length. Now increase r pointer by 1. Now what we will do, I will count vowel. No, how many vowel? For that, what we can do, vowel. What I can do, simply I check cats at what is the character of at index r. I can simply check that, and whatever, if it is a vowel character, it give me 1. If it is a constant, in that case, it give me 0. For that, instead of writing here, I can write here char c equal to s dot char at whatever at r, if it depends. So at that case, it give me value accordingly. If it is vowel, contribute 1, otherwise not. Now I check if my window exceed, if my window size exceed, what I will do, how can I check window? My r point difference between r and l plus 1, because our index start from 0. So in that case, I need to add 1. And if whenever it is equal to k or exceed k, in that case, what I can do, I will simply first I will track. Let's come here. What I'm saying, if it is if my window size is of k, in that case, I first track the maximum vowel count, and then I shrink my window. This is the idea. So what I will do first, I will first track the max count, max vowel count, like this. Whatever the maximum, it track that max max vowel, max vowel count, like this, and count whatever the maximum it stored that. Now what I'm saying, I'm saying okay, I have to shrink window, but how? If let's take this example. Now my L is at this point. If I am shrinking it, I have to decrease the vowel count as well. Why so? Because in this window, it contributing in vowel count. But when I shrink my L from here to, okay, from here to here, now this is not part of my new window, so in that case I can't consider the contribution of this vowel, so I have to reduce its contribution, its count value. So if my left pointer is pointing to a vowel, in that case I have decrease it uh, count value, because now this is not part of our new window. Hope so it makes sense. Let's come here. What I'm saying if my L is pointing to a vowel, in that case I have to decrease vowel count, because earlier it was included in my previous window and contributed in vowel count, but in this new window it is not going to contribute, it is not going to include, so I have to reduce its contribution as well. So simply I will check if my cats, how can I check that? If cats value is 1 at that index, if cats at that index is dot care at L, if at L my cat's value is equal to 1, because what we have done here, my cat, for vowel index, I have increased char value by 1. If it is char, it char's value will be 1. Otherwise, it will be 0. So if it is 1, it means that character at L is vowel. So in that case, what I can do, I simply reduce vowel count by 1, and in every case I shrink my window size. So how can I shrink? By moving my L pointer one place ahead, like this. Yeah, this is idea. Hope it's making sense. See, in this if block, what I am doing, I am just checking if my window size exceeding, I tracking the maximum vowel count till now for that window, and checking and shrinking the window. Before shrinking, we check first whether the left character is a vowel or not. If it is vowel, I reduce vowel count by 1 and I shrink my window. At last, what I can do, when I iterate over all the window, I have tracked the maximum vowel count, and at end I can simply return that max vowel count. Vowel count. Okay, let's submit it and see whether it's working or not. This is the algorithm. Here, uh, cats equal new cats. Okay, here we write int. Here we have to write cats because it is a cats array, not integer array. So yeah, let's rerun. Okay, here there is no any count value. We are using vowel, but I am using count out of habit. For every count we use count. Okay, no worries. And anywhere max vowel count, everything is right. Yeah, vowel. Let's rerun and see where else we have made mistake. Yeah, it is working now. Let's submit it as well so that we can see whether this algorithm is applicable for all test cases or not. Yeah, it's working there as well and giving us quite better runtime, because this is the average. Most people use algorithm, but here we are little at optimization side. So yeah, this is good algorithm. Okay, let's now it's time to analyze time complexity and space complexity. So let's first understand the time complexity. What the time complexity? Here I am running one for loop. I am iterating over my vowel only once. Uh, I am iterating over a string character only once. So in that case, my time complexity will be linear because I am running a single for loop. So the time complexity is linear. And what is the space complexity? Space complexity, sorry, time complexity is linear. And what is the time space complexity? Space complexity is constant. Why so? Because here we are using these three variable which take constant space. Variable takes constant space, and if I talk about this array, this is also taking constant. It for every test cases, no matter what the s length is, my char array is fixed to 128 length. So here my char array is also constant. It is not worrying with the s length. So in that case, I can say my char array is also taking constant space. So that's how my space complexity is constant for this problem, and uh, time complexity is linear. Hope so now you understood the algorithm and explanation. If so, please consider to like my video and subscribe my channel. Thank you.